Quite a few slides today. I'll try to go through them pretty quickly here. When Matt Heusser gives presentations at conferences like these, I think he gives great advice. It's really easy to just listen and listen and listen and go back to your day jobs without changing anything. His tactical advice, which I'm a big believer in, is write down 3 things before you leave the conference that you will actively change or look into more. My goal in today's talk, to be totally transparent, is to encourage you to seriously consider writing down, looking into this test design approach as one of those 3 things. I'm the founder and CEO of a test design tool, Pairwise. It's mentioned a couple times in the presentation. Smart testing and many other tools incorporate this kind of test design approach. I honestly don't care if you use our tool or other tools. There's a long list of very good tools, many of which are free, at places like pairwisetesting.com. My goal is to encourage you to use one of the tools because it's a really powerful approach that's not used widely enough, and I think it would help you quite a bit. Specifically, if you're already using these kind of approaches, use them more and more broadly. People tend to pigeonhole this test design approach and limit its reach. It's applicable almost anywhere, as we'll get into. If you've never heard of it before, start to consider using it. If you would like to learn more, I think 2 out of the next 3 speeches on the techniques track of talks will address similar themes and talk about how people have actually used this approach. Rob Sabarin has done surveys of people and looked at what is the single biggest challenge. You see it there. This is a test design approach that is designed directly to attack that problem. And let's be clear, we're not alone as software testers. This same problem has been faced by many industries. Srini Kulkarni is going to be talking later about, is testing dead? My favorite response to that is from Kem Kaner, who basically said, that's absurd. Testing as an industry is in its infancy. We're going to mature over time. My point is, as we do that, we should look to outside industries who faced our #1 challenge and developed solid solutions to it. From experience over the last 5 years, I can tell you these kind of approaches, borrowed from other industries, work extremely effectively in the software testing field. So this is a 2-part talk. The first talk is quickly about the experience at Apple Maps. They certainly face this problem. Too much stuff to test, not enough time to test it, with fairly disastrous results. We'll ask what happened, was it avoidable, and some practical implications. Then we'll dive into kind of the meat of the presentation in a little bit more depth of why is this approach used, what are the current adoption trends, and does this really work in the real world beyond PowerPoint presentations? And again, I'll try to move kind of quickly through this. Most people's careers look a little bit something like this. Over time, they'll gradually get more senior in their organizations with some minor ups and downs. This is a story about somebody whose career looks nothing like that. Scott Forstall had a meteoric rise to the heights that few humans can dream of. People were saying that he might become the next CEO of Apple. That did not happen. He was fired a few weeks ago as part of the outfall of the Apple Maps disaster. Even worse for him, I would not wish this fate on my worst enemy. If you Google the exact phrase, got what he deserved, his name is mentioned in 9 out of the first 10 results. So 1 minute, people think he's going to be the next CEO of Apple. Next minute, his friends are embarrassed to look him in the eye. Gets even worse for Apple. Another extremely talented guy, this guy's name is Richard Williamson. He led the Apple Maps development effort. Not only was he fired, but it's a big shame to Apple that he was. His name is on 17 different there are 17 different patents. He traced his history back to Apple, back to time with Steve Jobs at Next Computing, and he was heavily involved in some of the most phenomenally successful technology products in the history of the world, without exaggeration. The iPad, the iPhone. Can you imagine firing somebody like that? But he got fired as well. It's been a really bad thing for Apple. You Google Apple Maps disaster, 123,000 hits come up with that exact phrase. This was a bad thing. It culminated with the CEO's public apology, basically saying it's so bad you should use our competitors' products. If you're in software testing or software development, you do not want the CEO of your company publicly apologizing for a product you've been working on. I don't take any joy in highlighting that these guys have been fired, but it's just a reminder to all of us that there are sometimes dramatic results and consequences when poor quality products get out there in the market. So what kinds of problems were people having? Well, the vast majority of them were just common everyday problems. I was talking at this convention center yesterday in Bangalore. Can't find it on Apple Maps. Can't find Le Méridien on Apple Maps. You compare that to Google Maps. Not only can you find Le Méridien spelled correctly, ending in I-E-N, you can find it immediately if you spell it incorrectly. Some of these things are amusing here over these next few slides. On the left, you've got Google Maps with the street names in Tokyo and the train station there. On the right, you've got Apple Maps without this critically important information. You've got squiggly roads. You don't even need to restrict yourself to the land and roads on the land. If you look at places near the water, you've got big problems with the Brooklyn Bridge. It looks absolutely nothing like that. This is one of my favorites. You've got a restaurant in the middle of a canal. I wonder what the instructions and directions to get to that place are. You know, stop at Town Street, walk a couple hundred yards, get in a canoe, and go to the restaurant. You've got missing bodies of water. You've got the opposite of missing bodies of water. Bondi Beach in Australia looks 10 times larger than it actually is. You've got another one of my favorites. It looks like a modern art painting. You've got cars that look like they're melting into the streets. A lot of things were wrong with this, and that led people to make fun of the application. Here we've got a take on the icon of this application. Go halfway over the bridge, take a left, plunge off the bridge, and if your wheels are still on the ground, keep going left. You know things are bad when organizations like this are publicly making fun of you. For those of you in the back who might not be able to read it, it essentially is saying, you know, if you're using our flagship product, the iPhone 5, the majority of the people who answered said they were slightly less interested. In addition, another 20+% said they were no longer interested. Fortunately for Apple, those results were misleading and demand has been relatively strong, but I promise you the CFO of Apple was nervous about those kinds of data. It became a CEO, CFO kind of problem related to the quality of the software. Now let's be clear, they were doomed to failure. There's no way in the time they had to develop the software, as complicated as it was, with hundreds of different data providers to integrate with the scope of the entire world, that they were going to come out of the gate with version 1.0 that was going to be at an Apple level quality. There's just no way. So from that standpoint, it's unfair to be too critical of them. On the other hand, it was a disaster. Raises the question, could this total disaster have been avoided? I think yes. This is a bit of speculation on my part, but I think yes, and two things stand out. The first is, if you have really smart testers, and you listen to those really smart testers, there's a better chance that you're not going to say, well, we know there are defects, there are always defects. When's the last time that we've been happy, that the testing team has been happy to send something into production? Yeah, we'll just ignore them. If you have somebody like Harry Robinson, who just commands respect because he's brilliant, if you're in a rut in your testing career and you ever want to read anything inspirational or see somebody who thinks just brilliantly, research Harry Robinson. He's got wonderful stuff. Every single time I've listened to him or read his stuff, I've come away kind of a little more excited about software testing. Not only is he brilliant, he also led testing efforts at Google Maps. So he has deep subject matter expertise. You put that in combination with the fact that fewer people were willing to buy the iPhone because of it, and it had the potential to significantly decrease the market capitalization, the value of the entire company. Apple should hire him yesterday, and he'd be a bargain, without exaggeration, at $1 million a year for the kinds of insights that he could provide. Now, secondly, here's where we move from kind of fast-paced slides to what are we really talking about here? How can you achieve more testing coverage and fewer tests? Google Maps is much the same as Apple Maps, and you've got a huge combinatorial explosion at play. How does that come about? You've got 3 different kinds of transportation, right? You can get directions by car, or by walking, or by public transportation. That's 3 possible test ideas. Now, some people are going to want their directions incremented in kilometers, some people with miles. So we've now got 3 times 2, we've got 6 possible test ideas. Some people are going to push the get reverse directions button, some people won't. Now we've not got 6, we've got 12. And it goes on and goes on and goes on and goes on. From this single page alone, each of those ovals represents multiple different choices. You've got a total of 72 billion possible tests. Too much to test, not enough time to test it. What do you do? My assertion is that if Apple Maps had tested with this strategy and looked seriously at what are the most important tests to execute in the time we have available, they would have reached the conclusion earlier and with more conviction that they were heading towards disaster. How does this work? With our tool or any tool like it, you rely on the tester to thoughtfully think about what are the interesting things to vary in the system we have. They'll either do a good job with that or a bad job with that, but that's where it starts. So you identify things like, oh, there's an avoid highways or avoid toll roads option. That might be selected, it might not be selected. Once you've identified the kinds of things that might vary in your application, you push a button. And a tool like this will generate what? It will generate certain combinations for you that should be executed. We've got 72 billion to choose from. How can we prioritize those? By clicking on a Create Test button, you would be presented with a set of just 35 tests out of 72 billion. It's usually not nearly that dramatic, but in this case, 35 tests out of 72 billion to start with. It's not saying it's going to be the be-all and end-all, all the tests you need to execute, but if you've done a thoughtful job of identifying what interesting things you can vary, and you push a button, these 35 tests are going to be remarkably powerful. Why? 1, because they'll be as scientifically varied as possible. They're going to be, said another way, they're going to each involve the least amount of repetition possible. And importantly, as we'll talk about later, well, I guess right now, you're not only testing for each and every test input, not only testing for each and every feature, you're also testing for each and every feature in these 35 tests in combination with every other test input that you've thought of to add into the plan. I know I'm throwing a lot of information at you, but this is important. So one feature, we could have chosen any here. We could have chosen a data range. We could have chosen whether or not reverse directions are shown or not. We're just selecting this one randomly to illustrate the point. There's a feature called show more photos, where you can look at photos people have taken on a map as an overlay. Not only will these 35 tests make sure that that feature gets tested, there's going to be at least one test for that feature and every other feature. that has the More Photos feature tested with view it as a map. One test is going to include the More Photos feature tested with view it in a satellite format. This approach is sometimes called pairwise, sometimes called all pairs. Very, very similar, but slightly different to orthogonal array-based testing. That's what I want you guys to focus on and get excited about. Why? Because it's incredibly powerful, incredibly effective if you can do a good job at identifying the things that can be buried in your system. Implications so far. One, if Scott Forstall can be fired, anybody can. Disastrous quality can lead to really bad results for anybody. Two, a really smart tester like Harry Robinson can be extremely valuable to your teams. And what we're going to dive into more now, pairwise and combinatorial testing approaches. And we're talking about not the test execution part, but designing your tests, selecting the tests that you're going to execute. These kind of approaches, you can toss the orthogonal array in there as well, will help test your systems both more thoroughly and, if you want to, more quickly because you'll have fewer tests. So, does this stuff really work? Sounds nice in theory, and what are the adoption trends? The reason why it works is that if you look at the defect reports in your organization, they're going to be very similar to this, I promise you. We've looked at them for the last 5, 6 years. What this says is, if you think about how many test inputs would be required to trigger defects in production that snuck through QA and testing, the most common type are just a single test input. I don't know, in the Google Maps example, Apple Maps example, if you put in a destination anywhere in Thailand, if the database for Thailand was just missing, you'd only need one test input, and everything related to Thailand just would not work. Destination equals Thailand, things are broken, that's one test input. There are going to be a lot of defects. The next most common type of defect is in combination with something else. A pair of test inputs would be required to trigger a defect. That would be, for example, show reverse directions and zoom out. Zoom out on its own works, show reverse directions on its own work, but when you have a test case with two together, you run into problems. That's where defects are. If you think about it, that finding has huge, profound, practical implications on how we should all be testing. Because if we can design a set of tests that will test for every single interaction, every single pairwise interaction, we'll be much more thorough at finding defects. That's really what this is all about. Some people are a little skeptical when they hear this. How can these brainless computation engines design our tests for us? They don't. You are designing the tests. You're thinking about the test inputs that need to get into the tool. They're just helping to maximize variation, ensure that nothing gets forgotten, and to minimize repetition. If you ask pilots, surveys have been done, if they're average or above average at their jobs, almost everybody says, airplane pilots, they're way above average. So if you look at the person on your left, you look at the person on your right, we're going to talk about how manual tests are typically created, and I'm sure you're okay, but the person next to you is kind of putting tests together like this. So 2 different ways to design tests. One with a pairwise approach, the other with a manual approach. You identify the things that vary in your system. And if there's anything that's going to trip people up in trying to implement this in your jobs, it's that process. That's relatively hard. How do you identify what's going to be interesting to vary in your particular system under test? A lot of people struggle at that stage. But if you can get over that stage, the rest of it is really pretty straightforward. It doesn't really matter what kind of application we're talking about here. It happens to be an application that takes money from people who are saving for retirement. They might save it into plan A, B, or C, Might be in this tax year, that tax year. It might be the first time they made a payment, or it could be a monthly kind of payment that's going in. Could be received in several different types of funds transfer, and so on. But it really doesn't matter. The important part is everybody in this room has systems in their organization that have a lot of things to vary, and that means this approach is applicable to the kind of testings you do. If you have things that you can count, if you have relative positions at the top of the list, the middle of the list, the bottom of the list, if you have files in storage where data is supposed to be in one location but sometimes is in another location, if you have business rules tied to geographic locations, and so on, this kind of approach is applicable. It doesn't matter the specific application we're looking at now, any application you have can be modeled effectively that way. So now we've got plan types of A, B, and C, and so on, color-coded. That's kind of cool there. So when you're developing tests now, since we know this profoundly important information from the pie chart, that a lot of defects are going to be related to the interaction of just two of these test inputs, what we want to do is test not only each and every feature, but each and every feature in combination with every other feature. This is what it looks like when you put tests together using a pairwise testing approach or an orthogonal array-based approach. Highly efficient coverage of these kind of things just after 5 tests. You may not be able to see it from the back, but it's tested just about everything once, with the exception of, over at the top here, C and A haven't been tested at all. Fast forward another 10 tests, now everything has been tested at least once, and there's just a handful of things that haven't been tested in combination with one another. C up at the top has been tested with most things, but not with B in blue down here. Fast forward another 3 tests, and you've got everything covered, not only at least once, but in combination with every other thing. Sometimes these interactions between 2 values are completely and totally unpredictable. Sometimes they're straightforward. If you look at the problems that the iPad had when it first came out, with wireless connectivity sometimes dropping, the solution on Apple's help system was to lines represent missed combinations that hadn't been tested yet. Fast forward to 126 tests. These are actual manual tests that we've analyzed. You have certain combinations in the manual approach tested again and again and again and again, 42 times, 22 times, 22 times. And in red, combinations that have never been tested at all. This approach to covering things that matter works better. Period. Consistently. If you've done a good job at identifying the things that vary, there is no way that a human is going to be able to cover those combinations, the ones that matter, the ones that they think don't matter, nearly as efficiently and effectively as some computer-optimized system. Okay, nice, but so what? The adoption curve of this kind of approach is now currently going through a very strong uptick. We're a 4-year-old company. Our tool is used, I can speak to our tool alone, by more than 100 Fortune 500 firms. It's not widespread usage with hundreds of people at all of those, but it's seeing strong increases in adoption. Why? Because it leads to really significant benefits in a couple areas. I'm almost done here. One, when you're looking at creating tests, documenting tests, it's faster because you're pushing a create test button. And all of that stuff happens very, very quickly. 30 to 40% less on average. These statistics are coming not from our marketing department, but from studies that have done with 3 PhDs and published in IEEE magazines. Defects found per test per hour, because you have the increased coverage, because you're packing in more coverage into fewer tests, you're increasing the variation, you're decreasing the repetition, are dramatically higher. Either I'm just lying to you, or you should be interested in that number. I don't think there's any middle ground. 2.4 times higher consistently in terms of defects found per tester hour when you use this approach. And then defects found overall as well, also consistently increasing. Thank you very much for your time. I think there's a little bit of time to take questions.
Fantastic. Yeah. There's a question there. Mike, please there.
So from Collabra, the underlying logic that you're using to select the risk-based testing approach, you're basically selecting the lead out of the shaft. Is that that distribution that you showed, 51% with one input, 33% with two inputs? So you have an underlying logic. With time, that logic, that distribution would change, right? Because as you move, as the industry matures, as you have better product, that percentage distribution will change, and you will see more defects coming out of 4, 5, 6. So how do you vary your underlying model so that your pairwise test selection keeps getting more mature?
That is the best question I've ever heard after a general introductory session like this I've ever heard in my life. You're absolutely right. In early phases of testing, it may well be greater than 51% with just a single test input. As you get more and more sophisticated, if you're on release 8 of some stable kind of system, if you're sending something to the moon or outer space, if you're NASA, which incidentally uses this exact approach, NASA does, those percentages you see in that pie chart will change. And the easy to find defects will mean that as an application becomes more and more mature, the two-way will become higher than the one-way, and the three-way and four-way and five-way will become more significant. What that pie chart means for most people is if you have a very small number of tests to execute, it's a great idea to start with testing everything once, and then the next biggest bang for your buck is going to test everything twice. And what our tool and several others allow you to do is then say, you know what, we're Google Maps. We're not going to stop at 35 tests. Let's be realistic. It's possible that a defect could only be triggered by this and this and this all happening together. And so you can increase the number of tests. It's like turning a coverage dial. Let's go for not the best 35 tests, but the best 300 tests, or the best 1,000 tests, or the best 5,000 tests. So great question, absolutely right. And it's helpful to be able to have that coverage dial so that you can get to all three-way combinations or all four-way combinations.
Fantastic. Yep. We can take one more question.
Thank you. It was a very good presentation. We've implemented pairwise testing, but when I did some R&D on where is it applicable in terms of domains or in terms of what areas of testing is it applicable, I did not really find much help in Google. And I was always under the assumption that pairwise testing would not be applicable in networking and trafficking testing. But with your session now, I get to know it is more applicable in those areas. So can you shed some light on which domains it is applicable and what kind of testing can be done?
Yes. So you're absolutely right that there's very little written about that important question. Interestingly, ironically perhaps, the very first time that this was used was in the telecoms industry. AT&T Bell Labs about 20 years ago thought, hey, this design of experiment stuff that's used very successfully in manufacturing and advertising and agriculture and lots of other places seems like it could help with the problem that we have. Too much stuff to test, not enough time to test it all. So in AT&T Bell Labs, they used this approach, tested it out in telecoms, and found it was phenomenally successful. A couple of the guys who were involved in that kind of wound up creating tools for software testers like ours because it was so successful. But my answer is it's applicable in just about any industry anywhere. It's not applicable where you have just very defined short unit tests because they're not combinations to worry about. But anytime you have things you can count, relative positioning, files and storage, geographic locations, format, size, depth, timing, frequency, duration, input and navigation methods that can be varied, you've got lots of interesting combinations to consider. And this is a really good way of not getting 100% of your tests, but it's a really good way of getting a starter set to start executing that you would then supplement with other tests that you're thinking of, and negative tests in particular you'd probably want to add on to these. But every single industry you can imagine, just about everywhere you can imagine, except for unit testing, because it doesn't have complex combinations to worry about.
Thank you, Justin. And Justin is available whole day here, so those of you who want to have questions can certainly take it offline. But I think Justin said